Astrobots. I am 2 and this is my second video. So in this video we are gonna delve deeper into some electronic components. We are gonna look at every symbol and we are gonna do some basic electronic circuits. We are gonna draw some electronic circuits. Also we are gonna make some electronic circuits on a breadboard. So let's get started. So the first component is LED. It looks like this. It was all shown in the last video. All of these components that are here were shown in the last video. So if you haven't watched them, you can go back and look at them. So in an electrical circuit, the LED is symbolized like this. So the arrows going outward show that the LED is emitting something. Of course, it is emitting light. So the anode here stands for the positive leg and the cathode stands for the negative leg. So the positive leg is the longer leg and the negative is the shorter leg. So that's it for the LED. It is a really simple one. We are gonna use all of these components. We are gonna use all of these symbols rather and make an electrical circuit, a very simple electrical circuit. So the next on our list is a motor. The motor looks like this. It comes in various shape sizes, it comes in various powers, etc. Unlike the LED, the motor looks like this, and unlike the LED, the motor doesn't have a positive and a negative side, because you can connect the motor, you can connect the positive and negative ends of the battery anywhere to any leg of the motor, and if we interchange those, so if we connect the positive, suppose on the top side, and the negative on the lower side, the motor will spin in one direction, and if we interchange those wires, the motor will spin in the opposite direction. So that's one advantage of a motor. You don't have to look very much, means like the motor won't get damaged even if we connect the battery in any way. Unlike the LED can get damaged if we connect the battery incorrectly. So the next one on our list is a breadboard. So the breadboard looks like this. I showed it in the last video. This is not the symbol for a breadboard, but I just thought that for explaining the connections in the breadboard, it would be simpler. So if we look here, so if we look here, we've got the breadboard. So if we see here, the first section, second section, third section, and the fourth section. There are 4 sections, as I said in the last video. So the first section is connected like this, which is the top section here, and the second one is connected like this. The second and the third connected like this. So these two are connected like this, and the last one is connected like the first one. So that's it for the breadboard. It is all of its uses and everything was shown in the last video. You can go and check it out. So the next one is a switch. This is an on-off switch, simple on-off switch, and this is how it is symbolized in an electrical circuit. So switch SPST, single push single throw switch. This switch can only power it can complete only one circuit at a time. As you can see here, it is just used as an on-off switch, or it is used in our houses. So the next one is another switch. It is a simple one push button. So like when we push it, it comes up again. I have one of those, I will show it. It is symbolized like this in an electrical circuit. So in here, in this SPST switch, when these two lines are connected, the circuit is closed. That means the circuit is complete. Here, when these two circles, when this line joins these two circles, the circuit is complete. So this short line at the top symbolizes the red cap here. So when this is pushed, the two legs of the switch are connected, and the current is and the circuit is complete. So the next one is a switch, another switch. It is a DPDT switch. It means that it is a double push double throw switch. So as you can see in this symbol, it can complete two circuits at a time. So we can see here the first, second, third, fourth. So there are four dots in a line. So the first dot goes to one circuit, the second goes to another one, the third goes to another one, and the fourth goes to another one. So this switch is used to connect various circuits in one switch. This switch is we are going to use this switch in the car, in the robot or car, which we are going to make in the final video. So let's move on. The seventh is battery. So we all know what a battery looks like. I showed them in the last time. This is how a battery is symbolized to alternately a big line, then small, then big, and then small. So the big lines, the longer lines, show a positive side, and while the shorter ones show the negative side. So if we look here, there is a cell. So this is a cell, this is a structure of a cell, and this is a symbol of the electric cell. So if we look at these, when two cells are connected to each other, they form a battery. So when two or more electric cells are connected with each other, they form a battery. So if we see here, there is a longer and a shorter line. So here there are two cells connected to each other, hence it makes a battery. So this is a cell. This is a bit of extra information about the cell. If you want, you can take a screenshot of this and then you can study it on later. I'll keep it like this for some time. So I hope you have taken the screenshot, and let's move on. So now there are wires. So we also took a look in the last video at wires. So basically we will be looking at two types of wire in this series. One, it is a single stranded wire. So the wires come in a rubber coated, so they are insulated. So if we remove that insulation, there is only one single strip of metal in there. It is only one thick string. So both the wires are symbolized with one symbol only, which is a dash. Multi-stranded wires, when we remove the insulation on top of them, there are many wires. I will show them when we will be building the circuits. The next is the soldering gun. So this is how soldering gun looks. I also showed it in the last video. There is no symbol for soldering gun as it is not used in a electrical circuit. And there is a solder wire which is used to solder the components on an electrical circuit. So that's it for the components, and we are gonna now look at how to draw some electrical circuits. So I hope you guys have understood everything here. I will try to make this in a link available in the description. I will see if I can do that, and let's move on to drawing some electrical circuits. Hello everybody, welcome back. Right now we took a look at some various components and their electrical symbols, and now we are gonna go forward. But before drawing some electrical circuits, I got to know that in the last video I did not introduce the resistor. I'm holding one in my hand. So this is how a resistor is. Get closer, because it is a really small thing. So a resistor is used to decrease the resistance in a circuit. So there are some ways to identify the value of the resistor. The resistor has a specific value on it. So if we look here, so if we look here, we can see various colors on it. So we have got a brown, a black, and another brown. So I don't know if we can see that clearly, and one gold at the very end. So we are gonna be looking at how to get the value of resistor. So this is a resistor. So I took the camera closer. This is a resistor which is used to decrease the decrease the current in the circuit. So it is used when there are, suppose you have an LED which works at a lower voltage than the supply, which that means the battery you have. So the battery provides X current, and the LED uses up Y current. So we know that if we supply the LED with a larger amount of current, the bulb gets short, means the filament gets burned, the LED doesn't glow. So to reduce that, to prevent that, this resistor is used. So the resistor brings down the current to a specific value. So there is a way of measuring the value of the resistor. So we can see four colors over here. So to measure the value of the resistor, you have to hold it in this specific way. So the gold, so we have got brown, the second one is a black, the third one is also again is brown, and the fourth one is a gold color. So you have to hold the resistor in such a way that the gold color side is on your right side. So that's how we do it. So to understand more about this, we will jump on the computer and I will show you how to get the value of resistor. Welcome back, everybody. So we are gonna look. So this is a resistor. I showed it, and this is how it is symbolized in an electrical circuit. So how the resistor works is that it is made up of a specific type of material. So current is the flow of electrons. So when electrons flow from point A to point B, uh, when a battery is attached between those points A and point B, the current flows. This current flow is known as electron flow. So this the blue thing, this blue part you see here comes in various different colors. It can be type of brownish, it can be in various colors. So this blue part here is made up of a specific material which obstructs those flow of electrons. So thus the electron flow is reduced, and this is how it works. So the resistor decreases the current flow in the circuit. So there are 10 different colors on the resistors. So I could not draw a table here, but we are going to switch to Excel. So these are the colors of the resistor. So we have got black, brown, red, orange, yellow, green, blue, violet, grey and white. So the values are very simple, they are in increasing numbers. So black has 0, brown has 1, red has 2 and so on till white. White is the largest and it has got the value of 9 ohm. Not ohm, it has only a value of 9. So to remember this color code, there is a technique. So it is known as, so we can remember it by BB. So we can remember it by BB ROY. Good boy. Very good. Right. So we can remember it like this. So here, so in the first B and B, it stands for, the first B stands for black. The second B is for brown. The next one red, then orange, then yellow, then now the first letter of good only G, then B, then again V, then G, and then W. So here I will complete it and show you the final result. So here we are. So I completed this, the color code, so we can remember it by BB, good boy, very good wife. So B stands for black, brown, red, orange, yellow, green, blue, violet, green, and white. So uh, the value cannot be just removed by putting the values of every color here. So in this resistor, we have to follow a system. Um so the first two lines which we see here, which are brown and black, they are the numbers, so we have to substitute their numbers. So here, yes, so I got the table from the Excel sheet here, so we can see the color and its value here. So now the first two steps that we see here, we have to substitute their values. So if we see here, the first step is brown, so the value of brown here is 1, so we have to write 1 in front of the, so we'll take this piece to write the value of resistor, so we can write 1. And then the next step is black, so the value of black here is 0, so we write here 0. The next one is brown again, so here we don't have to write the value of brown, which is 1, we don't have to write the value of brown, but the value of brown here is 1, so we have to write the number of zeros the value of third step is. So suppose if now here it is brown, so brown has a value of 1, therefore we have to write 1 0 after the 10 we just now got, so that's 100. And after that there is a symbol of ohm. So there is the symbol of ohm, or we can just write OHM, ohm. So if we now suppose we consider the first step is black and the second step is, so the first step is brown and the second step is black, but the third step is suppose orange. So if the third step instead of brown it is orange, so what we get is that the value of the first two steps remains the same. So here we get again 10 of the brown, which is 1, and black, which is 0, and the third step being orange, we have to insert the number of zeros the value of as the value of orange. So orange has a value of 3, so we have got to increase 3 zeros here, so 1, 2 and 3. So this becomes a resistor of 10,000 ohms. So we can also write this as a 10k resistor or 10k ohm resistor. So this is how we can deduce the value of resistor by using this column. I'll put it in the description so you can refer to it. Now we will go on to making some basic electronic circuits. Hello, welcome back. So now we will be moving forward to drawing our own electrical circuits. So we are going to draw our first electrical circuit using the symbols we learned in the earlier video, and let's move on. So first, in this first circuit we will be using an LED, a resistor and a battery. So first we need to draw the LED symbol, so it is better to start at the top, then continue from right to left. So first we will draw the LED symbol, which goes like this. So if we know that this side here is the negative side of the LED, so we are going to put a minus sign and circle it, and the opposite side will be plus and then circle it. So this will be our LED. Even if we know the negative and the positive legs of this LED, we should always, while learning we should always write these signs so that we remember and we don't get confused. I think if you guys do these circuits with me, it will be better for understanding. So now we will do our resistor. So we know that the current flows from positive to the negative side of the battery. So there is no use in connecting the resistor at the minus side of the LED. So we should always connect the resistor to the positive leg of the LED. So right now we'll connect the negative sign of the negative leg of the LED to the negative end of the battery. So the negative side of the battery is the shorter line, then the positive, then the negative and the positive. So then we continue forward, and then we draw a resistor. The resistor symbol is like this, a zigzag line or bunch of mountains and valleys. And yes, for the LED there should be arrows coming out because it is emitting. You can even, there is no need to draw two, you can draw one. So this is first our basic circuit. This is the first one. We will do these circuits on the breadboard, which is this board. This will do the circuits on this one, and this is our first circuit. Then we will move on to the second circuit. So our second circuit consists of a buzzer, a resistor, switch, and an LED, and a battery, of course. So we will modify this first circuit to make our second one. So first our LED symbol, signs. So buzzer has a positive and a negative end. So this is how a buzzer looks. The black wire here is the negative end while the red one is the positive end. Unlike the motor, it has positive and negative ends. So we connect the LED's negative leg to the buzzer's negative leg. So we will continue it forward, and the buzzer is indicated, the buzzer symbol is like this, like a dome shape. So this is a buzzer symbol. So we need to write the signs. Now we continue forward, we go down and connect the ends to the battery. We will use a switch here. So this is our switch. The switch can be drawn either way, like this, or the opposite way, like this. Either way it is alright. So this is our switch. This is an open switch, means the circuit is broken. The switch goes to the battery, and then we add a resistor. So this is our second circuit. These are really simple circuits. So I will be putting some circuits in the description. If you want to try them out, you can try them. You can use these symbols. And now let's move forward to building. So now we will see this circuit on our breadboard. So I've got the materials ready. So what we are going to need is an LED, so quite maybe two, a snapper. This is a snapper, it is used for a battery, and a resistor. This is a resistor. So let's continue. So now we are going to take the breadboard. Now we know the connection of the breadboard. So now we insert the two legs of the LED in at least three holes apart. Why so apart? Because then it is easier to put these wires in. So this is our LED in. So why I will be using a resistor, we will get to know. So the basics is that you have to remember which side is the positive, which side is the negative of the LED. Otherwise we'll just have to remove it like a lot of times and then it will be just annoying. So we connect. So now I've got the snapper, and it is a multi-stranded wire. I will so we can see here that the snapper, this is a part of the snapper, it has got many wires inside it, hence it is called as a multi-strand wire. This is what a multi-strand wire looks like. So once we remove this red insulating material, we should just twist those wires so that they are together and they don't make a mess. So now we will join the positive and the positive ends of the LED and LED and the snapper. I will join and show. So I've joined so you just take them carefully and easily, you just gently push them in. If you push it too hard, the wires just bend and they won't go in. This is very easy to do. So now here in this circuit there is no resistor. There is no resistor. So once we connect the battery, the bulb, as we could see, the bulb became very dim. So it's like almost shining like nothing, and it has heated up a lot. So why did this happen? Was because this battery which we used supplied a lot of voltage to the LED than it required. Thus its filament, it got burnt and then it won't shine. So now we are going to use a resistor to reduce that current and make the LED glow correctly. So what we are going to do is we are going to insert another LED. You can insert it in the same place, but it is better to rearrange like this. So once you have done this, now remember that the resistor doesn't have any positive or negative ends. So the resistor should be connected to the positive side of the LED and connected in this row, and at least 3 to 4 squares away from the positive end of the LED. And now we will connect. So what we have done is we have extended the LED's leg. So the LED's original leg was on the LED. Now the LED's leg continues here. So now the LED's positive side is here. You can use it here, but then the circuit won't complete because this side is open. So now we insert the red wire in the open end, which is this end of the resistor, this end. So I will insert, just push the wires gently and they will easily slide in. If they won't, then you can just shake them a bit and it should be fine. So I've got the wires in, and now let's see. So we are going to connect the battery. So as we can see here, there is a colored LED. It glows, and it glows correctly because of the use of resistor. I'm going to disconnect because then the camera, it won't focus on anything. So it is because of this resistor that the LED's filament did not get burnt. So this is our basic circuit. So I will end it here. You can use, instead of a LED, you can use a motor, you can use a buzzer. Actually I will use a buzzer right now, and I will get it. So this is one of the buzzers that I have. It is a, you can get very small ones too, so but this is the one I have. So now we have got the positive ends of the battery. So we are just gonna connect them. So positive goes to the positive. I will join and show. So I've got it connected. I know the wires are a bit intertwined, but we see here that the red wire is connected directly to the red positive end, and the negative to the negative end. So I tested this buzzer. It has a really loud sound. I've connected the buzzer here. It is outside camera. Now it is inside. So this buzzer has a really loud sound. So if you have any volume warning, then please lower your volume. So the current the circuit works. We can even add an LED inside, but that will be for a future video. We will go into more complex circuits, and we will, if I can try, then I will also teach soldering in the next video. Till then, thank you for watching my video. Please don't forget to like, share, subscribe, and comment what do we need to do next, what improvements do I need, or what else am I forgetting. You can comment down below. Thank you. Over and out.